Welcome to This Explainer. Today, we're going to pull back the curtain on the hidden, living world of wastewater treatment. It's a fascinating process, one that actually mimics nature to keep our cities running.
So let's just start with a really simple question. You turn on the tap, flush the toilet, and all that water just vanishes. But where does it actually go? And the really big question, how on earth does it get clean again?
And here's the cool part. The answer isn't just a bunch of pipes and filters. It's not all mechanical. We've actually figured out how to harness a completely natural, biological process. We've basically enlisted this massive microscopic army to do all the heavy lifting for us. Okay, so let's meet this incredible cleanup crew. They're the absolute stars of a technology that's been around for, get this, over 100 years. It's a process called activated sludge treatment. Now, the name itself tells you a lot. This stuff is called activated sludge because it is literally alive and kicking. It's not just dead muck, it's a carefully grown ecosystem packed with bacteria, fungi, and protozoa. All of them just hungry and ready to chow down on contaminants, breaking them into simple, harmless stuff.
All right, so let's take a little tour, shall we? We're going to follow a single drop of water as it makes its journey from dirty to clean inside one of these plants.
Okay, this diagram here is basically our map. It's going to guide us through the whole process. Now, you'll see it mostly flows from left to right, but pay attention to that little loop in the middle. That's super important, and we'll get back to it. For now, let's just follow the water's path.
So first things first, before our little microbe army can start eating, we have to prepare their food. Think of it like cooking. You got to prep the ingredients, right? So first, a bar rack screen out all the big objects. Then a grit chamber gets rid of heavy stuff like sand and gravel. And finally, primary sedimentation lets some of the first solids just settle out on their own. All right, now we're getting to the main event. This is the heart of the whole operation, the aeration tank. This is where all that biological magic really truly happens. Okay, so what's happening here? The water we just pre-treated gets mixed with that activated sludge we were talking about. And when they combine, they create this rich, brown, kind of soupy mix that engineers call mixed liquor. The key ingredient here is oxygen. You'll see this mixture is constantly being stirred and pumped full of air. Why? Well, it's an aerobic process. That's just a fancy way of saying these little microscopic workers need to breathe, just like we do. The oxygen keeps them alive and super energetic so they can feast on all the waste in the water. So as all these microbes are eating and multiplying like crazy, something really cool happens. They start to stick together in these clumps, and these sticky, heavy clumps have a special name, flock. Now, making this flock is a huge goal of this whole stage because these heavier clumps are absolutely key for what comes next. So after about 4 to 8 hours of feasting in that aeration tank, our mixed liquor is now full of that flock we just mentioned. The eating part of the job is pretty much done. Now it's time to separate everything. So the whole mixture flows into this really calm, quiet tank called a clarifier. All that churning and bubbling, it stops. Everything just slows right down. And those heavy flock particles, well, gravity takes over, and they do exactly what you think they do. They settle to the bottom. And what's left at the top? Much clearer, treated water. That's the good stuff, called the supernatant. Okay, but what about that thick layer of sludge at the bottom, the microbes? Well, this is where the process gets really, really clever. Most of it, what they call return activated sludge, or RAS, is sent right back to the beginning of the aeration tank. It's recycled. This gives the new, incoming wastewater a big, healthy dose of hungry microbes to get things started fast. But, these guys are multiplying all the time, so you can't just keep them all. So a little bit is pulled out of the system as waste-activated sludge, or WAS. It's this perfect, delicate balancing act. That's the real art of running one of these plants. So let's just recap that core cycle. You mix the wastewater with the returned sludge. You aerate it so the microbes can eat and form flock. You let it settle so the clean water separates, and then you return most of the sludge to do it all over again. Mix, aerate, settle, return. That simple, elegant loop is the engine that drives this entire self-sustaining system. Okay, so this whole thing has been around for over a century. Why? Why is this biological process still the gold standard for cities all over the world? What makes it so incredibly effective? Well, there are some huge advantages. First off, it produces really high-quality, clean water at a pretty reasonable cost. That means healthier rivers and lakes for all of us. Plus, it's pretty compact. You don't need a giant footprint of land, which is obviously perfect for crowded cities. And maybe the most incredible part is how scalable it is. The exact same idea that serves a massive city can be shrunk down to work for a single hospital or a small community. It just works everywhere.
So that leaves us with one final thought to chew on. When you think about it, this whole system is really just a man-made, super concentrated river. It's a living ecosystem. We managed to do what nature does best, just way faster. So as we're all looking for more sustainable ways to build the cities of tomorrow, it makes you wonder, right? What else can we learn from this amazing century-old process that basically perfected recycling long before it was cool?